All right, welcome back, everybody. Sorry that I had to miss class last time. It was best for all of us that I wasn't here. We're gonna make up for it this week. I'm gonna record a video for R7 and 9.1, which we were gonna do Friday or Thursday. It's the easier section to make a video and have you guys watch it, and I'm gonna extend the homework for this week and next week's homework due dates. But we're gonna try to get caught up. Today we are covering factoring at one point early on. So this is gonna be on factoring. So what is this, day 3 that we're actually doing some shit in here? So we're looking at factoring, and M335 presumes you already know how to factor, and it's been a while. So this is good review. So when we do factoring, there's one, we can factor out the GCF, which stands for greatest common factor. Do an example of that real quick. If I have 5x to the 4th power plus 15x squared. One way of going about doing this, if you know or remember how to factor and can do it quickly, go for it. But otherwise, factor each of these over on the side. So 5x to the 4th is, it only has a 5. I'm going to do just the numbers in front first, the coefficients. 15 is 5 times 3. And the idea is to keep the things in a column identical. And then this one has x squared, which is x times x. And this one's got x to the 4th, which is x times x times x times x. So the greatest common factor is 1 from each of the full columns. This is a full column. There's an entry for every row. And these two are full columns. There's an entry for every row. So 5x and x, 5x squared. Now, if I were to make the table, I would probably simplify a little bit. A simplified form would be doing 5 and 5 times 3, and then picking whichever one has the smallest exponent. X squared has the smallest exponent, so I'm going to do x squared. And then I'm going to do the same x squared above it. And what do I need to multiply x squared to get x to the 4th? I need another 2 x's, so I would do that. It ends up being the same. If you do it like that, that's still the 5, this is still the x squared. And you can see this. Let me change back to a different color real quick. Black. We still got the 3 here, and we still got x squared here. So what we do with this, the GCF goes out front. Put 5x squared out front. And if you've done this table thing, everything that's left in the table that isn't part of a complete column is what goes on the inside. The 5x to the 4th has an extra x squared, so I have an x squared. I have a plus sign, we'll bring that down. And the 15x squared has an extra 3. Now, we did a table like this before with fractions and finding the least common denominator. The least common denominator was 1 from every single column. This one is only 1 from completely full columns. But it's a similar structure. If you want to, if the table thing works both ways, depending on how you want to use it. And again, you don't have to use the table if you are comfortable factoring other ways. If you look at the textbook that we're using, johnblakely.com/textbook, there's links to it in the modules and stuff. We are doing R4, which is on polynomials, that has factoring in it. But there's an entire chapter on factoring. If you want to skim through it, I'm doing a lot of similar ideas right now. I'm pulling like one from each area kind of thing. But if you want to do more in depth and look at it some more, there's a lot of examples in chapter 4. And he's got pretty good notes. Like he walks, if you look at it, in case you haven't looked at the textbook, it gives a bunch of problems and he shows what you would do at each step. If there's a bunch of steps, he shows multiple steps going down. And writes out kind of what he's saying or what he's thinking. So it is helpful if you want a refresher. I'm going to remind the Math 35 students about that because we're going to try to do as much of that as we can in the next 45 minutes. Do you guys want to try to do an example on your own of factoring out the greatest common factor real quick? Let's just make sure you guys are with me. Let's do, you try. We're going to have 3y cubed minus 27y to the 7th power.
It's still in the textbook.
Ah, shit. Thanks. Thank you. But it's a glorious textbook. Trying to switch my material to his because it's free for students. And it's written by someone at COS. If you do it correctly, you're going to get 3y cubed times 1 minus 9y to the 4th. That's just the GCF step. This one actually factors further. But we're going to go over that. We'll come back to this problem later on to finish factoring it. So I made the table. I grouped my y's by the lowest exponent, which was q. And I'm basically figuring out what the exponent is. I needed to add up to 7. So 3 plus what equals 7? 4. So that's the exponent that goes there. So we got the 3y cubed, that's clear. And the minus came down from above. I can see the 9y to the 4th right here. Here, there's nothing left. Nothing left doesn't mean it's 0, because this was technically 3 times 1, so there's still something there, it's not a 0. So that's how we end up with a 1 there. We just generally don't write down 1s when we're saying what are factors of things, because everything's got a 1 in it.
Question.
Yeah,
So if the y to the 4th power on the bottom was on the top, just say it was, would that be 9 minus y to the 4th power? You see what I'm saying?
if we had the 27 up here and the 3 down here.
If just because like there
Yeah, we could have had 9 minus y to the 4th.
because on the top, the 5x to the 4th plus 15x squared. See how like the 3 is on the bottom and then the 2 x's are on the top and they're separate?
Yeah.
Is that the reason that they're separate? Is because one's on the top, one's on the bottom, they're not both on the bottom?
Say that again?
So like the
Up here,
up there, the x squared that we get,
uh-huh,
it's separate from the 3, right? It's x squared plus 3 in the parentheses.
yeah,
And it's not like the bottom where it's 3 times 3, which is 9 times y to the 4th power.
right.
It's separate.
Well,
Because-
they're separated by rows.
Okay,
So this x squared is that x squared right there, this 3 is that.
Yeah.
Here, if we separate by rows, there's nothing in this top row. That's how that part's done, does that make sense?
Yeah.
Does that answer your question?
it does. Thank you.
Alright, and this does factor more, we're gonna come back to it. So there's other things we can do. That's always the first step with factoring. The second step of factoring is count the terms. Remember, terms are separated by plus or minus. If there's 4 terms, we will factor by grouping. If I could put an example on here for under the 4 terms to do, and there's not fucking 4 terms in it. I don't know why I chose that as a fucking example. It's fucking confusing. Maybe it's the one I want to do for GCF. We'll go back to that later. 3 terms. This is trinomial factoring. It's generally, oftentimes, you'll see the form ax squared plus bx plus c is a common form. But there are more complicated ones. And then C, 2 terms, 3 terming, what the fuck? 2 terms. This leads to something called special binomials. And there are 3 of those. First one is a squared minus b squared. That is a minus b times a plus b. Or you can do the plus first, like that. This one is called difference of squares. A is squared, b is squared, and difference is the outcome from subtraction. So that's where the name comes from. Alas, if you try to do sum of squares, the sum of squares, it doesn't factor into real terms. It does have complex factors. But we got to cover complex numbers first before we hit complex factoring. That's not today. That'll be Thursday. Thursday's we're doing R4 and R5 today. Thursday is just R6 in its entirety. It's a long fucking section. It's got an entire chapter just for itself too. So this one's a no-go. Nothing to factor yet. It's the +1 for squares doesn't work. Now, if we look at cubes, these are the other forms that have special binomial factoring. A cubed minus b cubed. And IV is that 4th one, a cubed plus b cubed. These are very similar factor forms. Both of them start off with an a and a b. And then they have an a squared. And then ab plus b squared. And I'm leaving gaps because I'm going to put in a different symbol for each of them. But they have that part in common. Now, when you're figuring out what to fill in, the sign that's the cube goes in the first one. And then in the second blank spot, you do the opposite sign. So this was a minus, this becomes a plus. This was a plus, this becomes a minus. And these are called the difference of cubes. And sum of cubes, respectively. And there's no shortcut other than memorizing the formula. Like, there are other ways to get this, the sum or the difference of squares. There's other ways of factoring that still results in you getting this. You don't have to memorize this one, but it is convenient. It speeds shit up for memorizing difference of squares. This one, you're not gonna pull this rabbit out of your hat. If you have this as something cubed minus something cubed, without the formula, I don't know how they fucking did it. I think it was just guess and check or some shit. I don't know. Whoever came up with the formula was brilliant. Those are kind of what we're doing. Let's go through some examples. Still right. So factoring by grouping. Let's have. X cubed minus x squared. Plus. 4x minus 4. When we factor by grouping, we put them together in pairs. Either do first two, last two. Yeah, or sometimes first and third works and second and fourth go together. But usually when I mean first two and last two, I mean with the exponents going down as you go left to right. If you have them in a different order, put them in this order before you say first and two and last two. So once you're there, you do the greatest common factor in each one. So these both have an x squared in them. And this would leave behind an x minus 1. That's if you did the factoring table. Or if you get comfortable with factoring, pull out the one with the lowest exponent. And then see what you would have left. Now, if grouping works correctly, this is going to show up again. If grouping works. So, and it goes the other way around. So you might like factoring the thing on the right first. And then saying I should get that on the left. What do I need to multiply x by to get 4x? 4. So that's what I did. I looked at here and said, what do I need to multiply to get that? That's what goes out front. I can double check it. 4 times x is 4x. 4 times -1 is -4. Double check these real quick too. X cubed and -x squared. You can always verify that you did the right thing before you go. So I'm going to rewrite that line down below without all the arrows on it. Now, this is one term. And this is a term. They both have x minus 1 in them. So that is the greatest common factor. These two pairings. That's what we pull out and put in front. Since it's got a minus sign in it, we're going to have to use parentheses. And left behind an x squared plus 4. Okay. That's how we do factor by grouping. We'll do a little bit more complicated version in the main class, but that's the The beginning one. Well, let's look at trinomial factoring. The easiest form is this form. No, the easiest form is this form when A equals 1, and a lot of teachers start with that, but I'm not going to. So the idea here is find two values that multiply to A times C and add up to B. And these will be numbers, not letters. All right, let's start with we're gonna do 10x squared plus 13x minus 3. Now, I like to do a little table here. So I'm gonna show you the table over here. I like to do A times C in one column and B in the other. So I'll put A times C here, and I'll put B here. A times C is 10 times -3, which is -30. B is some combination of the factors. We don't know what they are, but it needs to add up to 13. Everyone with me? All right, so here we can do a little bit of logic first. This will help narrow shit down. I have two numbers that multiply to a negative number. Which means what? One is negative and one is positive, exactly. So one is negative, one is positive, but they add up to a positive number. Which tells us what about the negative number and the positive number? The positive number has to be bigger, because if the negative number was bigger, the B would be negative. So we need a bigger positive number and a smaller negative number. So what I'm going to do is I'm going to start with the most basic one, -1 and 30. And I'm going to make a list of a bunch of them right now, just so you see how it goes. I'm going to keep going up a number in this column. And if it works, I'm going to make a line for it. -4, -5, -6. I'll stop there for now just to illustrate what's going on. -2 goes into 30 15 times. 3 goes into 30. In fact, we've got -3 and 10 right there. That's those two. -4 doesn't go evenly into -30. I'm going to cross that one out. -4 doesn't go in. -5 goes in. 5 times 6 is 30. So -5 times 6. And I get to -6 times 5. And now the bigger number is the negative number. And this one doesn't work. This one won't work. Because it's going to have a negative number. Now, if you add these two numbers up, this is 29. This is 13. This is actually the one we're looking for. I'm going to keep going because I want to illustrate something to you. Keep adding these up. This is 1 and this is -1. If you do this table format, let me let you guys write this table down first. It just takes up paper when there's small factors and you can kind of guess and check. I'll show that method in a little bit. Guess and check is only useful if you can do it in your head though. Because otherwise guess and check eats up a lot of fucking paper while you guess. So. And this table is designed to have one number consistently increasing by one, or in this case, decreasing by one, going down the list. What's going on with these numbers over here? They're in order and they're going down, aren't they? That will always happen. They'll either always go down or they'll always go up, depending on how you, what you have over here. But the orders are, they're always increasing or always decreasing. So. If you're doing this and you've got like your thing, your A times C is like -90, where there's a shitload of combinations. You can literally do like 1 and then jump past it. If I did like -1 and then -5 or -3, I would know that 13's in the middle. Let me put my pen over it to kind of illustrate that. If I just check -1 and then I check -3. I skipped -2 and my number skipped my target number. So it means I gotta go back up and go into the target range. That only helps speed up the table a little bit. The idea here though is what we wanted. And more importantly, this is what we want, the -2 and the 15. -2 and 15 is how we're gonna divide this 13x up. This is gonna be -2x. Plus 15x. There are other ways to do it, but this is a nice systematic approach that always works. All right, now we do it by grouping. Okay. So I'm going to start with this one over here. 15x and 3 both have a 3 in common, right? If I divide 15x by 3, I get 5x. And if I divide -3 by 3, I get -1. And I have a plus here. If I do it correctly, the 5x minus 1 should appear again. And I can see if I want to get -2x, I start with -1. It's got to be 2x out front. Yeah.
I actually have a question on this stuff. How would you, if you had a formula like this and it was full of decimals, what would you do?
If the decimals ended, I would multiply everything by 1 followed by another 0 so they didn't have decimals anymore.
Yeah. Yes.
And if I needed to, I'd put a fraction out in front that undoes that. So if I multiplied by 1,000, I would put 1/1,000 out front. That way I didn't change the value. In some cases, just multiplying through by 1,000 works. All right, so now this 5x minus 1 is in both groups. We pull that out. And what's left over is 2x plus 3. And if we need to, we can always multiply this back out. I don't know if we've done foiling or multiplying polynomials. I don't think we have. I think we're reviewing that today. We'll cover how to like check this later on. This table is easier if the number in front is a 1. This whole process is easier. A times C, there's a 1 out front for the A. A is 1. C is 6, so A times C is 6. And B is -5. Now, if I multiply two numbers and the outcome is positive, it means either one of two things. Both of the things that I multiply together start off as positive, or they both start off as negative and they cancel each other out. And the sign of B will tell us which one it is. B is negative here, so it means two negative numbers cancel each other out. So if I were to do it systematically, I would do -1 and -6, -2 and -3. And when I get to -3 and -2, I can see that actually these are the same two factors. This is the same, so I don't even need to go further. I don't even need that one. So we only need the first two. -1 and -6 add up to -7, -2 and -3 add up to -5. So I'm gonna do the grouping again. Even though there's a shortcut, I want to do the grouping to show you the shortcut. So this tells us our factors. We have -5x becomes -2x and -3x. And then we're gonna group them up again. Group. This is an x squared, so there's no number in common. The only thing this one has in common is an x. This leaves behind an x minus 2. If done correctly, that x minus 2 repeats. What do I need to multiply x by to get -3x? -3, right? Since I kind of cheated, and I just said the next thing had to be x minus 2. I'm gonna verify that I still get the right thing. -3 times x is -3x. -3 times -2 is +6. And that is what's there. And these two are x squared and -2x. So that was a good factor. So add x times x minus 2 and -3 times x minus 2. The x minus 2 is common to both sections. So I can pull that bad boy out. And what's left behind gets its own parentheses. So that's the long way of doing this problem. When a equals 1. So like x squared with no number in front. Notice that these two terms appear right there. So you can jump straight to from the table to the solution. I think I need a -8 right here. I just made this number up on the spot and I think it's not gonna work if it's not a minus. How did I just rewrite that part? There we go. It wasn't gonna factor. Alright, so they gotta add up to a negative and they multiply to a negative, which means one of them's negative, one of them's positive. And the bigger number has to be negative. So I'm gonna do 1 and -8. 2 and -4. 4 and -2 would be the next one. But here the bigger number is not negative, so we don't need that one. This adds up to -7 and this adds up to -2. Rather than doing that grouping, I'm just going to jump straight to putting these into parentheses. X plus 2 and x minus 4. The grouping thing always works. It's more work when A equals 1, but this shortcut shit doesn't work up here. A was not 1. And it didn't fucking work. If I plugged in -2 and 15, I get the wrong shit. So. One method always works, one method is gimmicky. This one's much easier, obviously. And a lot of high school teachers and stuff teach that one first, which I think is making it really hard for fucking students to learn the harder method. If you start with the hard method, which always works, then you show the gimmicks.
Yeah, like that method's the method I was taught, and it was always really annoying having to just kind of like muscle it through whenever there was a value on A.
Right,
So I'm like, I have to like make a much larger table. It's
right.
So I'm like, I was curious, I'm like, let's say if it was 101x² plus 2367x minus 8056. Like,
Well, first I would try to see if there's any common factors of all of them and reduce it that way. But sometimes you just kind of have to do the brute tackle approach. At that point, I'd be lazy as fuck, I just started doing an online factoring thing.
alright.
That'd be just ridiculous at that point. I do want to show something good about the table that a lot of people don't recognize. So like, what if we had something like x² minus 3x, I don't know, minus 16? I'm making it up as I go. So A times C is -16 and B is -3. So my bigger number's gotta be negative. So I'm gonna do 1 and -16, 2 and -8. 3 doesn't go into -16, 4 and -4. And after that, we start going back and repeating. Now the bigger number is going to be the positive one if I keep going, so I'm not gonna keep going. If I add this up, this is -15, adding left to right. 2 plus -8 is -6, and 4 plus -4 is 0. By following the table systematically, there was no 3, cross off the 3. We followed the table. But skipped -3. If there was a -3, it would have been in here. And since we skipped it, D and F does not factor. A lot of teachers teach the guess and check method, which works really well when you're good at factoring already. Doesn't work very well if you're not good at factoring. And it will never fucking tell you if it doesn't factor. I can't tell you how many students that are fucking hooked on the guess and check method try like 2 fucking things and go, nope, doesn't factor. I'm like, the fuck it doesn't. You just didn't try all the fucking things you guessed. So guessing check sucks. But the table, if you skip the number, it's not factorable. All right, let's do one of the square or cubes real quick. I'm gonna do the squares and the cubes. So let's say we have 4x squared minus 9. This falls under that two terms category we were talking about earlier, and I'll bring up again in the main course. And our options for this category were a squared minus b squared equals a minus b, a plus b. We had a cubed minus b cubed equaled a minus b, a squared plus ab plus b squared. And we had a cubed plus b cubed. That equaled a plus b, a squared minus ab plus b squared. I'm just rewriting down the formulas. Because we're gonna do a little example for each of them real quick in the whole fucking 2 minutes we have left. There are only two terms here. I see a square here, so what I'm gonna try to do is write this as two things squared. 4x squared is really 2x squared like that. 9 is really a 3 squared. So this fits the whole a squared minus b squared if a equals 2x and b equals 3. So if you have them written as squares like this, you quite literally make two sets of parentheses, throw this in the front one of each, throw this one in the tail end of each, and you put different signs between them. The difference of squares one is probably the easiest one if I can remember. The cube one's got more shit to remember, but once you remember one, they're so similar, you get like two, it's like a twofer. Then we'll make this one a little bit simpler. No, we won't. Fuck it. I'm gonna say 8x cubed minus 27. This was lazy. I used the same fucking terms.
So,
This is 2x cubed minus 3 cubed. So this is an a cubed minus b cubed scenario. So I'm looking at a minus b, a squared plus ab plus b squared. If I plug in what I have, I'm gonna just plug in everywhere I see an a, I'm gonna put in a 2x. And everywhere I see a b, I'm gonna put it in 3. And since that second group has some squares going on, I'm gonna use some inner parentheses. So 2x minus 3 is still good. 2x squared is 4x squared. And 2x times 3 is 6x. And 3 squared is 9. That is the factored form of 8x cubed minus 27. And with that, we hit 301. I stole some of your time.